Welcome back. In this video, we are going to find the volume of two solids, a right triangular prism and a cylinder. These are both examples of solids that can be understood by stacking congruent copies of a base. Let's begin with a right triangular prism. We have this prism, and let's suppose we know that these sides of this triangle are 5 and 9, and the length or the height of the prism is 3 centimeters. So all of these are in centimeters. The first step is to look at the triangular base, B, the area of the base. For a triangle, the area was 1/2 base times height. So we just need to work on that first. For this particular right triangle, we can see that the base is 9 and the height is 5. So we have 1/2 times 5 times 9. This gives us 22.5 square centimeters. So now let's actually use our volume formula. The area of the base times the height. We just found the area of the base to be 22.5. The height or the length of this prism is 3. So we have 22.5 times 3, which gives us 67.5 cubic centimeters. So the volume of the right triangular prism is 67.5 cubic centimeters. Let's pause and think about what this means. Basically, since this is 3 centimeters long, there are 3 layers here that we need to consider. Each layer of this prism has an area of 22.5 square centimeters. If we stack those through a height of 3 centimeters, we get the 67.5 cubic centimeters of space inside our solid. That is why the formula works. We are multiplying the amount in one layer by the number of layers. Next, let's find the volume of a cylinder. Let's suppose we know that the base area, the area of the circle, is 35 square inches, and the height is 12 square inches. This is nice because the base area is already given, so we don't need to find it. For a cylinder, just like for the prism, the volume is base times height, since we can still think of this as stacking layers. The area of the base is 35 and the height is 12, which gives us 420 cubic inches. So the volume of this cylinder is 420 cubic inches. This is another great example of the stacking idea. A cylinder is also built from congruent layers. Each cross-section parallel to the base has the same circular area, so the formula is the same. This is an important connection for students. Prisms use area of the base times height, and cylinders also use area of the base times height. Even though the bases look different, the structure is the same. That is something worth emphasizing in teaching. Mathematics often becomes simpler when we focus on the underlying pattern instead of just the appearance of the shape. You are doing good work here. You are not just using formulas. You are connecting the formulas to geometric reasoning. In the next video, we'll move to pyramids and see how their volume compares to the corresponding prism.